Okay, welcome back everyone to Architecting in a Complex World. Our next presentation is Achieving Agility and Stability in Large-Scale Software Development by Ipek Ozkaya. As the last presentation, this one will end with an open dialogue period in which you can ask questions, and we'll address as many as we can. Ipek is a senior member of the technical staff in the Research, Technology, and System Solution program here at the SEI. She is currently engaged in activities focusing on large-scale agile and architecture and works to develop, apply, and communicate effective methods to improve software development efficiency. She is a frequent presenter at academic and industry conferences and co-author of several articles on subjects including agile architecting and architectural technical debt. Ipek, all yours.
Thank you very much, Shane. So this afternoon, I'm going to try to focus on two goals. One, I would like to leave away the audience with techniques that they can apply when they're grappling with applying agile software development in complex environments. And two, I'm going to walk you through a particular scenario of how architecture and agile software development could gel well. The reality of the fact is the wars between agile software development architecture, this process or that process, seem to be coming to an end. Yet, when we look at the customers that we work with, it still seems to be not common knowledge and common practice how these techniques and practices that have really benefited quite a number of organizations can be mainstream. And I'll end with two examples that will showcase some of our experiences in a generalized way, and then we'll leave some time for questions and answers. So I'm going to start with challenging us all. Have we been asking the right questions? So far, so much of time and effort has been spent in terms of trying to understand how much should we architect. And unfortunately, this resulted in the process wars, agile software development, rational unified process, waterfall, or whatnot. Yet, we leave the essential question not unanswered, which is when should we architect? And by the end of the presentation, hopefully I will have motivated that it actually should be a interweaved practice and balance throughout the software development lifecycle, including the sustainment phase. And I bring a concept that some of the agile thought leaders have put forward very successfully. It's a balance of anticipation versus adaptation. And let me demonstrate the extremes that we live in. In one extreme is the focus on priority that has come to bear with the more rapid, iterative, incremental, and agile software development approaches. I think it's a valid position to say I'm going to develop these features that my customers, my end users value first. Yet we've observed on and on again, too much focus on the functionality first results in a declining velocity, which often reflects itself as issues with architecture and a substantial amount of rework and defect resolution. On the other end of the spectrum, which we observe a lot with what we call highly regulated environments, I think the examples are not just our government sectors nowadays. The financial institutions, healthcare institutions face this. They need to go through certification assurance processes, hence they prefer to spend a lot of upfront time with analysis and design. Yet, the hope that one time the delivery will spike has never served its promise. So the question that we ask in this complex environments is, how can we get this integrated value and what are the practices? So we will focus on that question mark, and I will argue that you can't leave neither agility nor architecture behind, and there are actually some experiences now out there that could help move forward.
Okay, so our first polling question with Ipek, we'll give you about 15 or 20 seconds to vote, and then we'll share the results as we did with last presentation. And that question is, which software development process are you currently using? Number one, agile software development, e.g. Scrum, XP, test-driven development. 2, waterfall or phased-based development. 3, RUP. 4, organizational, specific, iterative, and incremental development. Or 5, none of the above. So we'll take about another 10 or 15 seconds, and then we will share the results. And we have them up now. 100% agile software development.
Wow.
Scrum, XP.
All right. Well, I'm actually glad, because I think that means you are both living in the world that I experience, and also hopefully we'll get some conversation ongoing both at the end of the presentation and later on in terms of the challenges, whether they align or are there other challenges that we have missed. And that is actually what we observe as well. The reality has been there's a big movement toward agile software development, Scrum as a management process, but a lot of the others have come up with all these flavors of iterative and incremental software development. So, and that also relates to the rest of my presentation, which will take Scrum development context as an environment and show some technical approaches in terms of integrating architecture. The symptoms of failure that I, as a professional working with organizations, observe all relate to not being able to manage the complexity and the scale. And some of these that we work with is, for example, teams, and these could be Scrum teams, product development teams, so I generalize in that context. There's a lot of time spending trying to fix defects and catch up, and then new capability development continuously starts slipping. Or there's issues with integration of products while each team might be actually succeeding in a particular velocity and developing to their backlog, yet when multiple teams have to integrate their products, the end-to-end functionality doesn't result in the expected behavior. Hence, there are a lot of quality attribute concerns, architectural concerns that need to be revisited. Not any one particular team can really handle. And the last one is actually an interesting one, but I want to put it out there, which has a lot of relationship to architecture, although it's not recognized as readily, which is as a result of challenges in testing or being able to include testing into the sprints or development cycles, testing costs starts rising, and similar to architecture activities, testing activities start declining as well. So as a result of observing these symptoms, what we observed and generalizes, it's not necessarily a lack of understanding of applying the techniques, but it's a lack of understanding of the complexity of the scale. And scale does not just mean managing a large project or managing a large team, and it has aspects. So we deal with scale from three different perspectives. One is scope. Obviously, the scope of the system might be either new, might be more complex, but that's not just necessarily in terms of the technology aspects, but it's also related to maybe there are downstream or upstream software development or system development activities that you have to relate to. One of these complexities in terms of scope actually comes back again several times in terms of balancing and integrating systems engineering and software engineering activities. For example, when you develop embedded software, this comes up because there might be a separate systems engineering organization that may not be embracing agile software development, and there might be mismatches in terms of not only the development tempos, but also in terms of the expectations of outputs and inputs, which contribute to the scale and complexity of the scope. The second one is team. Typically now, we are working with multiple teams, and these multiple teams might be distributed, or it could be just even in a local, same location, they might need to be operated by independent parties. And the teams may also bring heterogeneity. So it's not just maybe multiple scrums or scrum of scrums you're managing. There's a lot of good information out there that can help you in that regard. But it's now different functions that need to be integrated as well. Like, for example, are there testing organizations that you need to coordinate with to be able to push this along? And how does that complexity in the team scale contribute to the issues that you might be observing in terms of the development effort? And the last is time. Time is a tricky one because a lot of the time we focus on looking at the development life cycle and the releases, maybe 2-week scrums or whatnot. However, time actually has a very significant influence in terms of the duration of the product that's going to be out in the market. And this could be not only related to the time it will take in development, but it will be the time it will take in sustainment. The typical reaction is, well, if it's a new project, it's not my problem, it's going to be the next team's or next project's problem. Yet, it might come back and really bite the teams, especially when unexpected technology upgrades need to be integrated into the product's development effort.
Okay, so we should have another poll here, folks. I'm aware of the last poll question. It might have been a little slow loading, so if you didn't see that, or if you're having problems seeing this one, just feel free to type in the chat as well. And that would explain our 100% vote on last time, Ipek, that maybe we didn't get the whole audience. So should be on your screen now. The question's asking, are you currently doing development in large-scale contexts that can be captured by extended scope, team size, or timelines of scale? Please choose one. And our options are large team size, larger than normal scope, longer development roadmap. Number 4 is product expected to be in service for a long time. Or number 5, at least 2 of the above. So we'll take about another 10 or 15 seconds of vote. Again, if it's not appearing for you, just feel free to type into the chat, as that is valuable feedback for us to capture. And I'm going to go ahead and share the results with everybody now. And it looks like we got some more diversity this time, so hopefully that went out for everybody. Almost 68% saying at least 2 of the above, Ipek. The next closest is 15.5% product expected to be in service for a long time.
Right.
Is that typically what you see?
Yes, that is typically what I see, and especially the product expected to be in service for a long time introduces the other challenges, especially with evolution and sustainment, and also the continuously changing scope because technology changes. And I think that's also in line with a lot of the systems that we see out there in terms of managing them. So how are we addressing these challenges? So what we've found out that because our argument, and I think any software development professional who's been out there and have experienced these challenges will relate to the fact that it's a balance of the techniques and the values that agile software development has brought to the table, as well as a really good understanding of the architectural issues. So we have a root cause analysis approach to it, and I'm demonstrating here the areas that we focus on, which span organization, product, and technology, and the measurement aspects. But I only have time to cover a number of these, but I'm hoping that it will provide you enough insights in terms of how you might go through this kind of an analysis. So the goal of this root cause analysis is to understand where you might really be failing. If you're failing in not applying a particular chosen project management technique like Scrum or a particular technology, that requires a different solution than if you have really blown and have not been able to understand your architectural significant requirements, hence continuously trying to catch up. That's a different problem. So the goal of going through the root cause analysis is to be able to separate the concerns and focus on the ones that are really the issues. I will start with response to change. So the response to change requires both function requirements to be understood, but also the expected tempo of change. A lot of the organizations that deal with large-scale and complexity issues, in fact, know particular architectural significant requirements to be stable. Those will not necessarily change overnight. So understanding those upfront is not necessarily an upfront architecturing activity or a waterfall activity. It's actually good engineering. So if you don't know the change aspects of your environment and how you need to respond to the change, then you might actually be facing issues that you could have avoided. And are there processes and technologies that you can handle when change comes? Because when you are, especially if you're in an environment where you have to deal with a large scale in terms of the user space, you might need to respond to those environments pretty quickly, especially, for example, IT-based development, web-based development, services that are in terms of web products do need to respond to these changes pretty quickly, do experiments in terms of understanding what users react to better or not. That requires well-established technology and processes to be in place to both manage the changes, but also have them go through the process. And the last point that I will focus on is the waste. Do you understand where you're actually failing? And this could be in terms of the high number of defects, that could require you to actually change your priorities, or it could be an unidentified technical debt. We call technical debt as an area that you might have needed to do a particular shortcut, and now you have to go back and change, but you haven't, or you haven't even recognized that particular suboptimal decision have been made and still are in the product that is affecting your response to change. The second is the culture. I think it's important to introduce culture for multiple reasons. First of all, in today's environments, whatever approach you're using to software development and efficiency, you have to empower your teams and you have to motivate them. This requires understanding both the communication channels and the decision-making channels, and also making sure that the appropriate number of people with the right skills are put into the teams. While this might seem as very clear and no-brainer, we actually often see this mismatch in good organizations even to cause a lot of issues in terms of adopting more iterative and rapid development life cycles in complex environments. I will change gears and focus a little bit on the quality attributes. You've heard the previous talk by Rob Wojcik focus on the importance of quality attributes and techniques for eliciting them. More often than not, especially in contexts where agile software development have been embraced wholeheartedly, we see a lack of understanding of the difference of architectural significant requirements and functional requirements. This results in, especially downstream, a lack of understanding of where the issues might be and substantial amount of rework. And I'm pretty sure quite a number of you have been there, like, for example, security and availability and fault tolerance are actually the three big areas that we observe being part of this mismatch. The mismatch happens because the quality attributes have not been elicited. People have in their mind that they might have an understanding of it. They had experienced professionals there and assumed that it would be a byproduct. But another very, very important trap that we see very experienced even professionals fall into is assuming that the development environments and the frameworks and the subsystems like tool environments that you're using will take care of some of them. They would maybe in smaller projects, but when you have projects that you will have to sustain for longer periods of time, assuming that quality is inbuilt in the frameworks that you're using is not sufficient. So it still calls for understanding your quality attributes, creating a measurement environment so that you know what happens in terms of, for example, end-to-end fault tolerance, end-to-end latency, so that you can empower your teams, and you could also assign the backlog priorities accordingly to the sprint teams or the development teams. And last but not least, let's focus a little bit on architecture. Architecture is not just a shelfware, and I think I'm hoping we are all agreeing on this. I don't mean the documentation that should go into it, but similar to the quality attribute reasoning, you need to be able to understand what is the evidence that this architecture will satisfy the particular expectations from the requirements. And how are the functional requirements assigned to the architectural elements, and can you actually decouple some of the dependencies so that the teams could, again, sprint with the expected velocity at their particular areas. Again, we see architecture-focused technical debt appear again here. This is a symptom of not being able to architect for the particularly highly challenging quality attribute scenarios, and maybe going back to it in an inefficient way later during the development lifecycle. One of the things that if you do nothing in architecture and quality attribute reasoning, one thing that you could actually do as a takeaway is, have you actually made particular critical architectural decisions and clearly scheduled them? Like, for example, if there's a particular technology trade-off that you're trying to decide upon, when will that decision take place? No decision is worse than any decision sometimes. And understanding when is the drop-dead deadline for making some of these hard decisions that impact architecture will also have a lot of problems and challenges as you go through the steps. So what I'm going to do next is I'm going to spend some time describing what might actually be some tactics to consider in terms of weaving these practices together. And this comes from my and my colleagues' experiences working with organizations and also interviewing organizations in terms of how they deal with these challenges in environments where they have to scale, but also use some way of iterative development to be able to respond to the agility concerns of their business environment. And I will walk you through a hypothetical example demonstrating how Scrum and architecture development could be aligned. I picked Scrum because assuming many of our audience would relate to it, but this could still work if you're just having multiple teams that need to coordinate. So I'm not necessarily assuming a Scrum one for all, but I thought that would be an easier way to communicate. So the three I'm going to talk about is aligning feature and system decomposition, creating an architecture runway, which for any agile software development professional is probably a terminology now that is known. And the last is being able to matrix teams and the architecture. I would like to stop and put some emphasis on the importance of understanding the dependencies and how they align with the functionality, features, and the architecture that you develop. We see more and more again that understanding how dependencies between not only requirements, but also how those requirements are allocated to architectural elements and how the architectural elements depend on each other become an area of issue if they're not understood well. And this actually has impact all the way to the testing activities if you don't have a good understanding around them or have a good way of managing them. And this doesn't necessarily mean just impact of change or modifiable or extensibility issues, but it has impact in terms of other quality attributes that are critical at runtime as well. So one way to start with is understanding how you are going to decouple parts of the system and how does this relate to the way the stories depend on each other versus how the architecture depends on each other and the mapping between them. The manifestation of the issue actually is very clear when we look at different kinds of systems, and there are typical ways that organizations react to this. And there's a tension between first focusing on high priority features and then first focusing on architectural issues. Organizations that have the focus on high priority features typically come up with an architectural footprint that is probably over-abstracted here, which we call the feature-driven approach. What happens is there's an end-to-end feature development that might be assigned to teams, and the system is decomposed vertically to be able to respond to that decomposition. In architecture-focused organizations, they actually, decomposition and the dependencies take a different toll, which we call the infrastructure-driven approach, where there's a horizontal decomposition, for example, in this case, layers that I'm exemplifying here. So the organization first looks at how to architect the system and then lays over the features to them. What we've seen is succeeding organizations actually are those that can balance both the infrastructure-driven approach and the feature-driven approach. So the step one of understanding this might be, what are these long-term services and utilities that you could actually provide for the development teams so that you could then start focusing on the features and have the teams develop for the particular functionality that the end users expect. An example, or two examples that to demonstrate this might come from how you might use frameworks or plugin interfaces. And I will go back to the improved technology of our environments. I think with whichever domain we're talking about today, there are existing frameworks, there are existing interfaces that common services we could take advantage of. And being able to take advantage of these also means decoupling the teams and the architecture so that you could progress in parallel in terms of the different kinds of functionality that you would want to develop. Here, The key will have to be when you develop the plugin interfaces or the frameworks, when it is introduced, and how then the teams are allocated to those particular functionalities so that you could continue sprinting while being able to rely on that existing infrastructure. I think some of the available IT-based systems take more advantage of it, or they are much more advanced in this. Yet, I think the technologies and the know-how is also significantly advanced in other domains as well. For example, embedded software. And we're seeing some of these ideas emerge there, especially with the mobile technologies and app kind of development environments taking a peak. The next tactic that I'm going to describe is creating an architectural runway. You can't just start development on day one. This is definitely understood both by agile proponents and also other development teams. Scrum calls this sprint zero. That might take longer duration as from the rest of the sprints. But what happens during that time is establishing those infrastructure elements, deciding on the frameworks, deciding on the interfaces, making sure there is a focus on architectural significant requirements. This doesn't take as long a time as it's assumed in some organizations. It actually goes a long way. And I've been starting to recognize that many organizations now have guidelines for their architectural significant requirements, quality attribute scenarios, in fact, sometimes. And they guide their development teams to make sure that those areas are at least thought of if they are not covered within the project's development. And that could happen as part of the architecture runway development or sprint zero if you're using Scrum. Leffingwell and colleagues actually correlate this with the size of the system in terms of the large scale. The bigger the system, the longer the runway. There are cases where this may not necessarily hold true, but I think the idea behind this is, going back to the polling question we have, if you have sustainability concerns for the product, if the scale of the scope or the team or the time of the development is an issue, you need to spend more time in architectural activities during that, or more emphasis on the architectural activities, and understand what might change and what might not change. This could be coupled with maybe some systems engineering teams or infrastructure teams or testing teams, and there might be creative ways that you could come up with parallel development if you spend enough time with your runway development. And the last tactic that I'm going to focus on is using matrix teams and the architecture. If we look at the vanilla Scrum definitions, the Scrum teams are actually similar in their composition in terms of developers, testers, and architects working together. And if you're working in a multiple Scrum environment, we typically see the same composition repeated with different areas of the system. So establishing, if that's the approach that your organization is following, maybe the sprint zero or the runway establishment takes advantage of those Scrum teams and assigning them to establishing a particular infrastructure to help the system prepare for the coming teams to be able to sprint upon. Once you are able to establish that common infrastructure, and this does not need to be a full-blown architecture activity, the architecture is not necessarily complete at the end of the runway development or sprint zero, but you have the basic building blocks that you could have some of the teams to go away and start customer-facing features. Once you have that environment ready, now you could actually change gears and have the parallel development go on. While some of the team members are continuing to establish that architectural framework, you could now start assigning across members across teams or teams within members within teams to particular feature development. This, in a way, goes back to what I motivated in the beginning of this talk, which is you have to balance architecture and agility, which means you have to have people developing features to demonstrate to the customers, as well as you have to have team members developing the architecture. Taking advantage of your teams creatively in terms of their responsibilities is actually a way to go for that. So here, what I'm demonstrating is, well, in particular Scrum teams, there might be people who are actually developing the features that might be cutting across the infrastructure, and they might themselves be creating a Scrum themselves and coming with a Scrum of Scrums. Might be one particular organization that you could take advantage of, both architecture-focused and agile-focused development. Once you have that infrastructure going, you could actually now start changing the balance. In the first several sprints, maybe the balance of architecture and feature development favors architecture more. Yet, once you have an infrastructure established, now you're ready to actually assign more teams to the development of the features. Again, this takes advantage of what you've already established within the architecture framework and can actually help decouple some of the dependencies between teams. This, of course, requires understanding the dependencies between the features as well as the architectural dependencies. Again, it goes back to the initial motivation. That is not necessarily just a modifiability or extensibility concern. It's a project architecting approach that you can take advantage of throughout the release planning and the road mapping activities. And in one particular example, we actually saw an interesting take on this. Well, once the different teams are assigned to the features, you could actually create a temporary team, sometimes maybe for a spike, or it could be for preparation of the system for the next release, where they might be now focusing on, again, architectural issues across different parts of the system, while separate Scrum teams might, again, taking vertical slices through the system and continuing with the development effort. This, in one way, is a way of looking at it as a dynamic teaming structure, but it also keeps the knowledge of the architecture known across different team members and enables them to make sure that the end-to-end functionality is established. Because when we say scale, more often than not, we're talking about multiple teams to be able to be coordinated, whether they are development teams, whether they are development versus integration or testing teams, but there are multiple professionals come into play that might need to work through different development cycles. So to put it in context, I'm going to give you two different examples that come from organizations that we worked with, and we use the root cause analysis that I talked about in the beginning of the presentation, and also came up with some areas where we saw the challenges and also some suggestions. If you find your situation similar to these, this might actually be a starting point to start looking at a solution. So the symptom that in one example, which was inability to manage both scope and the time aspects, and the issue that was apparent was the Scrum team spent a lot of time fixing defects, and they weren't able to focus on adding new feature development as there was a slip in the schedule, and also there were morale and whatnot kinds of issues. When we look at the root causes, the issues came from a lack of understanding where the product specific and the general focuses was. So this was actually skewed too much in terms of looking at the runway. They did a more general focus rather than product specific. And then the priorities of the issues, because of the time pressure, got all mixed up. As a result, the team was pushed to deliver an immature product. And as they were trying to develop and release the product, they said, well, maybe this would be easier. So they started introducing a lot of variation of the parameters that needed to interact, yet they weren't able to manage that. On top of it, because of the complexity in terms of the multiple release cycles, there was a customer-facing release, which had many variants. There was a testing release, which again had different variants. And there was a development cycle, which was monthly. But those different cycles were not integrated, and that also created a lot of issues because different people were involved. And even in the cases where there was cross-cuts, they weren't able to align their issues. So the first step for them was to make a deliberate choice to stop developing features and go back and look at their architecture. Obviously, this Increased amount of variance of parameterization did not help them. So simplify the architecture and clarify the architecture runway where the teams would sprint. So that actually helped the organization to take that step back rather than trying to keep up with the sprint cycles. And once that was established, they replanned the release cycles and the time boxes, and then they were able to revisit their testing strategy and team assignments because now they had a simpler system to work with. The second example comes from the scale in terms of inability to manage teams, and again, scope. And in this case, the issue was the integration of the products. What happened is there were, excuse me, multiple teams that were focusing on development, yet once the systems started to coming together, they recognized that they weren't able to actually coordinate well. Hence, the different teams had different interpretation of the interfaces, and the product owner on each Scrum did not necessarily see the same big picture. As a result, there were a number of mismatches that occurred. Interestingly enough, they weren't able to recognize it until the time of integration because these individual Scrum teams were, in fact, on track until the time that this integration happened. So the cross-team coordination was significantly poor. So in this case, there was an issue of their implementation of how to manage multiple teams. But again, the first solution point that we gave to them was postpone adding new features for a couple of releases because as new features, as new features got added, the complexity and issues actually got worse. And again, they identified and collapsed common services across teams. And this again went back to the runway, understanding what were some of these common interfaces and services that the teams could expect, and what would be the end-to-end features that the runway would actually have to take care of so that the sprinting teams could take advantage of those existing platforms and the services for the purpose of the product. So to end with some final thoughts, if you're seeing issues, I think we all fall into that trap. Rather than blaming either the software development approach you're using or the technology or the team members or whatnot, step back and do a systematic root cause analysis. This is actually easier done than it's typically assumed, and understanding the risks and putting them on this page goes a long way. Agile software development does incorporate some of these with the retrospectives. However, sometimes what happens in the retrospectives is because they're team focused, they might not necessarily propagate to the systematic issues in large-scale software development. We are all in agreement as a software development industry now today is it's not just one or the other. For high-quality products that meet their business goals in a timely manner, you have to embrace principles of both agile software development and software architecture so that you have both visibility into the project but also ways to manage it. And I talked about a couple of these, and we've also written about them as well. And the last thought that I want to leave the listeners today with is architecting is not a process step. It's an ongoing activity throughout the software development lifecycle, especially for products that need to be in service for a long time. You need to understand the quality concerns, you need to understand the teams, and you need to understand what will be actually changing in the business. And because this is an ongoing activity, you need to integrate it into your thinking, not only early, but in an ongoing basis. So it's an ongoing activity regardless of your choice of process. That's, I think, the time that I have today. There are some references for those interested listeners that you could go to. And with that, I'm happy to answer any questions later as well for those that Shane will not have enough time. And I think we're ready for some questions.
Okay, thanks, Ipek. Yeah, we got lots of questions coming in. First one to address actually came in the end of the last presentation, and I thought it may be applicable to you, so I'm going to ask it. If not, maybe we can bypass it. But from Krasmir is asking, can you share experience with agile teams working in iterations? Do you use QAW in each iteration from the very beginning of the project, and are people enthusiastic about this? Okay. Is that in your wheelhouse?
So, yes, I can answer that question. The quality attribute workshop or understanding quality attributes, whether you use the workshop or not, first of all, needs to happen at the beginning of the project. It is not always an enthusiastic activity for developers because sometimes the assumption is, well, this is the business work or this is the work of the requirements engineers. Yet once they understand that it impacts their day-to-day tasks, they actually get enthusiastic about it. And we have examples and case studies where we've used it with different techniques. In that case, we use it in the early part of the software development, and then we revisit them, especially when there are major changes. But it's not an activity that needs to happen every sprint, but it could be an activity maybe that could happen every release. So.
Okay, next question from George asking, what is the difference between root cause analysis and business process reengineering? I thought root cause analysis is strictly for incident management and or problem resolution.
Could you repeat the question, Shane?
What is the difference between root cause analysis and business process re-engineering?
Okay.
I thought root cause analysis is strictly for incident management or problem resolution.
Yes. So the description that I provided there for root cause analysis is, in fact, for incident management, issue management, and we developed this because when in situations that we use it, is typically one example is we're trying to adopt agile software development, but we can't get a handle around it because we don't want to let go of our architecture processes. Of course, if the organization chooses to use Scrum, there are Scrum coaches and all that, but we help them focus on the issues so that they don't let go, for example, some of the key successes they might have. Other situations that we use it for example, very successful Scrum teams, but they still cannot get the end-to-end feature and they don't know what might be happening. So that's actually the context that we use it for. It's not for business process re-engineering. There might be other techniques, and that's not the goal for it.
Excellent. Okay. Donovan would like to know, where can I find any and really all additional information on the hybrid decomposition approach?
Okay, that's a tough question because the hybrid decomposition approach, I mean, we can talk about the generals of that, but it actually has examples in terms of the domain-specific ones. Like, for example, when you look at some of the publications out there, let's say coming from real-time embedded systems, they actually have some of those architecture footprints. But if the individual is willing, I can send some examples of those, but I think you will see different examples of them depending on the domains. The generals are typically in terms of the general understanding the quality attributes and understanding the Scrum alignment, but the actual architectures that result from it will change from domain to domain. But I'm happy to send some examples to move forward for that.
Great, and we're getting lots of questions. Just to reiterate what Ipek, before we started, was there's a Saturn group, folks, you can sign up for, post questions there. Ipek did provide her contact information, or you can always send stuff to info@SEI, and we'll be glad to address all the questions you have. Question from Sushan asking, in vertical decomposition and horizontal decomposition, is the direction of the dependency important?
Oh, yes. And that's actually where if I understand the question is in terms of the direction of the dependency, like if you can decouple the features, then you are actually making sure that you are separating the concerns, and there might be some features that could actually happen on their own. When issues arises, when there are actually end-to-end services that span multiple features and you're not recognizing those, and then the directionality of where the features depend and how the architecture becomes important is an issue. In the horizontal one, there are architectural patterns that you could take advantage of, but in that case, what happens is a delay in delivering features. If you really need to start delivering, it might actually push you to too much focus on the upfront architecture, so that's really the issue of the balance there.
Okay, we're going to squeeze in one more question from Ipek from Daryl asking, in my experience, teams planning based on user stories often allow it to drive them toward feature-based plans and overlook infrastructure needs. Do you have recommendations on how to manage this problem?
Yes, I am on the same page with the question asker. I skipped his name. I apologize. I think one suggestion is do an upfront quality attribute analysis. I mean, Rob talked about it. If you do the workshop, it's just a day or two effort. Or just make sure that you focus on what are the key quality attribute concerns. And I'm going to repeat this. For systems that need to be sustained for a longer time, these do not change overnight. So you would actually know them with just a simple technique up front, and then making sure that they're managed throughout.
Ipek, thank you. Excellent presentation. Folks, that's all we have time for this presentation. We're going to start back up at 3:10 Eastern Time. That'll give us some time to prepare our next speaker. So we will talk to you then. Thank you.